Hi everyone, so today we're going to write polynomial equations given zeros. So there are two things that you have to remember. The first thing is always remember to write your polynomial in factored form first, and then you're going to multiply your factors to write your function in standard form. So the question that you always want to ask yourself is, from what factor did your solutions come from? As we go through these examples together, that question will become more clear to you. So we want to write a polynomial function of the least degree in standard form that has the given zeros. And you're going to assume that the leading coefficient is 1. So when you are given zeros, these are the same thing as solutions. So you want to think, from what factor did those solutions or those zeros come from? So an answer or a solution of 5 came from the factor of x minus 5. If I set that factor equal to 0, I would get an answer or solution of 5. Now that negative 2, that came from the factor of x plus 2. And the 0 or the solution of negative 1 came from x plus 1. So this is writing our polynomial function in factored form. These are all factors. And now we're going to multiply to write in standard form. So we're going to take our first two factors and we're going to multiply them together. So you're going to FOIL or use double distribute and use your box. Then we're going to combine our like terms. So that gets us that negative 3x in the middle. And then what we're going to do is we're going to take those two parentheses now, and we're going to multiply. And after we multiply, we're going to go ahead and see if we have any terms that we can combine. So we do have some x squared terms, and we do have some x terms. So when we combine our like terms, our polynomial function is x cubed minus 2x squared minus 13x minus 10. Now we're going to write a polynomial function, still in standard form, but now we're going to give you a graph. So you're going to have to find the zeros from your graph. So you're looking at 3 different places where your function is actually going to hit your x-axis. So remember, the zeros are the same thing as your x-intercepts. So at negative 4, that factor is x plus 4. At negative 3, that factor that the solution came from was x plus 3, and then that positive 1 came from the factor of x minus 1. So when we multiply again together, we're going to FOIL or double distribute, combine our middle term, and then we're going to go ahead and multiply. We're going to find any terms that have the same x squares and also have the same x's. And when we combine our like terms, we get x cubed plus 6x squared plus 5x, and then the minus 12. One thing that you want to think about is sometimes you could have repeated zeros. And what that means is that a factor is raised to an odd degree, which you just saw, so it all is raised to a degree of 1 or any type of odd degree. Your graph is going to pass through your x-axis. Now, that's what we saw in the last two examples, but let's say our factor is raised to an even degree, like a 2. The graph is actually going to bounce at the x-axis. So that repetition of that 0 is actually called its multiplicity. So let's look at this graph. What you will see is that you have two x-intercepts. The x-intercept, or that 0 at negative 1, is going to pass through that axis, but the 0 of positive 3, notice that it approaches that 3, it hits that 3, and then it bounces and goes off in the other direction. So that 0 of 3 is actually going to have an even degree. So that negative 1 and that positive 3 are going to come from the factors of x plus 1 and then x minus 3. And because the graph bounced at 3, that factor is going to be raised to an even degree, which is 2. So we've talked about multiplying imaginary zeros in a different unit, but let's just refresh what imaginary numbers are. So when we simplified square roots that had a negative radicand, we used the idea that I was equal to the square root of -1, and if I happen to square both the sides of that equation, I squared would equal -1. So we used those two when we were dealing with complex numbers. So if we were going to take kind of the same idea as what we've looked in the past several examples, and let's say we wanted to multiply numbers that had I in it, we're going to, again, use distributive property to multiply. But then if you happen to get an I squared, you're just going to replace it with -1. So let's look at this expression. So we have x plus 5i and x minus 5i. Notice we could FOIL, do our double distribute, put it in a box. We get x squared and then a minus 5xi, a positive 5xi, and then a negative 25, and then I times I got us our I squared. So what you will see is actually that the negative 5ix and the positive 5ix will actually cancel out, and that -1 comes from the fact that you had that I squared. So if I have -25 and that was multiplied by that I squared, or that -1, that's actually going to turn into a positive 25. So to simplify this expression, we get x squared plus 25. Now, let's look at this polynomial. Again, we're going to write it in standard form, so we will have to multiply, and we are given these zeros. So we're going to have some imaginary zeros here. So same ideas and the same approach that we've done before. You're looking at what factor did it come from. So if you had a negative 2i, it came from, right, opposite sign, it came from a positive 2i. And if you had a positive 2i as your zero, that factor came from x minus 2i. Now that 1 was still, again, that factor it came from was x minus 1. Now when I go ahead and I multiply in order to get standard form, I actually want to multiply the factors that have my i's in it. So again, FOIL, double distribute. Notice that the ix and the ix for the 2's are actually going to cancel. I do have the I squared, which turns into a -1, and that simplifies to x squared plus 4. So the green and the yellow becomes x squared plus 4. And I'm going to take that x squared plus 4 and multiply it by that first factor that I had in red, which was the x minus 1. So when I multiply again using FOIL, double distribute, my area model, my final answer is going to be x cubed, then a minus x squared, so we're writing in standard form, plus 4x, and then a minus 4. One more example here with you is that, again, let's say we've got 0, -5, and then, oh, here we go, I have a plus I or a negative I. That's that plus minus comes from x minus I and x plus I. -5 came from x plus 5, and then that 0 came from just x. Now you could put x minus 0 or x plus 0, but notice that you don't really need to include that. So the 0 came from the factor of just an x. Let's go ahead and multiply the imaginary together. Notice that the ix will cancel, that I squared becomes that -1, right? You do have the imaginary one that was in front of the I squared, so that becomes x squared plus 1. Now what we're going to do is we're going to multiply that red x with the x plus 5. So we're going to get x squared plus 5x. Now I have a binomial times a binomial that I can multiply together. What I will get as my final answer for my polynomial function in standard form is x to the 4th plus 5x cubed plus x squared, and then plus 5x. Now here are some things for you to remember. Remember that those imaginary solutions always come in pairs. So we always want to put a plus minus in front of those solutions if they aren't already given to us. And then always ask yourself, from what factor did your solution come from? And notice that your signs are going to change. So if you had a 0 or a solution of, let's say, positive 5, the factor that it came from would be x minus 5. Now I hope you found this video helpful and you're able to write polynomial functions given zeros. Thanks for watching and have a great day.